Hello everyone, welcome to this new video of different variation assignments. So now in today's video we are going to learn a very interesting concept, and that is called as, let me just first write it here. Okay, so these numbers are called as Armstrong number. So what basically is an Armstrong number? That is a very important concept. So let me explain that to you with the help of an example. So for example, if a number is 1, 2, 3, let me just take it as 4, okay, for now. So 4 is a number. How many digit number it is? That is a very important point of concern. It is a 1-digit number, right? So because 4 is a 1-digit number, therefore I have to first find out the number of digits, right? So we can say that it is a 1-digit number. I will just write it here, it as 1. Okay, so it is a 1-digit number. Now what am I supposed to find out is, I have to find out if it is 1-digit number. I will then say 4 raised to power 1, and the answer will be, I can say it as 4 raised to power 1 is 4 into 1, right? So it is equal to 4, right? Because anything raised to power 1 is equal to the same number. Therefore the answer will be what? The answer will be 4. So we can say any number whose raised to power, the number of digits will be the same, and then we have to find out the sum. I will tell you that in the some other digit, taking another digit example as well. So for example, let me take another digit as 153. Okay, because it is a 3-digit number. So what are the digits? 1, 5 and 3. So now these are 1, 5 and 3, right? These are the 3 digits present in this number. Now how many digit number it is? 3-digit number, right? So now what I will do is, I will write it as 1 raised to power 3, 5 raised to power 3, 3 raised to power 3. We will calculate the answer. 1 raised to power 3 is 1. 5 raised to power 3, it means we have to multiply 5 by 3 times. So it will be 1, 2, 5, right? Similarly, 3 raised to power 3, it means we have to write down 3 into 3 into 3. That is equal to 27, right? Add up all of these numbers. It will be equal to 153. Therefore, the number which we have obtained, this is equal to the original number given to us, right? Therefore, this 153 is an Armstrong number. Hope you guys understand the logic behind it. Similarly, if I will take another number, say assume 371. How many digit number it is? Again, it is a 3-digit number. What are the digits present in it? 3, 7 and 1, right? Now again I will write it down it as 3 raised to power 3, 7 raised to power 3 and 1 raised to power 3. If I will say 3 raised to power 3, it is what equal to? It is equal to 27, right? Now 7 raised to power 3, it is equal to 343. Similarly, 1 raised to power 3 is equal to 1 again. Now add up these 3 values and it is equal to 371. Because when you add up these 3 values, the answer will be 371. It is equal to the number given to us. Therefore, this number is also an Armstrong number. Hope you guys have understood the concept, the logic behind what an Armstrong number is. I'm going to remove all this. Now, what we are going to do? Number 1 step, we will first of all take a number, say n or whatsoever variable you are going to use. We will firstly store this n into a variable taking as temp. Why? So that we are going to definitely iterate it and use it again and again. Therefore, I will be taking this n number and save it into a variable called as temp. Then step number 2, I will first of all try to find out the number of digits present in the number. Why? Because every time I have to cube that up. If the number is 4-digit number, then I have to raise them to that number, right? So therefore, second step, we will be find out the count of digits. Well, we know how to count the digits by dividing it by 10, right? We already know that concept, how to find out the digits present in a number. Third step. Now is the most important concept where we will be taking the power. We have to calculate the power. Now, how to calculate the power? We have a formula for that. So for example, I will show you this with the help of the example. Firstly, let me calculate the number of digits present in the number. How we are going to do that? 153 is my number. I will take divided by 10 because 10 is the base number. So 10 ones are, it will be 10. Remainder we are getting is 53. Again, I will divide it with 5 and I will get the value as 50. So the remainder which I have got is 3, right? Remainder is 3. We do not need the remainder over here for now because we are only getting the number of digits, right? So if the first iteration has been completed, I will save this quotient into the temp variable. Initially, I will just explain you again. Initially, the value of temp was what? 153. After this first iteration, I will take another variable, say count, and it will be given the value 1 over here for completing the first iteration, right? Because we are only finding the number of digits. Now the quotient to me will be, I do not need the remainder because I want how many digits are there. So the first value will be, of course, 3, but I don't need the number. I need the count of digits, right? So temp value is now 15. Again, I will divide this 15 with 10. So it will be 10 ones are 10 and the remainder I will be getting is 5. It means here the temp value will get updated to 1 and the count value will get updated to 2. It means we have also iterated the second digit of the number. Third, I will divide this 1 quotient with the 10. Again, the value will be what? 10 zeros are 0 and the remainder will get is 1. Therefore, now the temp key value will go up to 0 and the count key value will go up to 3. Now, because it has already turned up to 0, it simply means we are not supposed to iterate it further. And the value of the count has also been increased up to 3. It means we have got the count of the number of digits present in the number and that is equal to 3. This was our very first task, right? Now, the second step. After calculating the number of digits present in the number, the count of digits. So I will say it over here that count value is 3, okay, and the temp key value, again I will give the n key value to temp so that I'm going to use this temp again for calculating the power now. So what I will do now, I will take a variable sum and initialize it to 0. Why? Because I have to calculate the sum as well of all of the cubic digits. I will write a statement over here. How? I will write the very first digit. What is the temp key value initially? 153, right? 153. Please make a note over here. I will divide it this time again and I will find out the remainder. Why? Because what we have to do, we have to find out 1 raised to power 3, 5 raised to power 3, again 3 raised to power 3, right? We have to achieve this target. So how we are going to do that? I will divide it firstly with, so it will just lead to 1, 10 further, then in the remainder will be 53, it will be 50 and the final remainder will be 3 right now, right? So we have 3. What I will do now, I will say 3 raised to power 3. I have to do this operation. How am I supposed to get this 3 raised to power 3? And I will store this value into sum, right? Similarly, now the quotient is what? 15 again. So I have to go divide this 15 with 10 again and 10 ones are 10. The remainder will be 5. Next time I have to do what? Sum is equal to 5 raised to power 3, right? Because the remainder is 5. It means every time I have to get the remainder. How am I supposed to get the remainder? I will do one more iteration and after that we'll generalize it because 1 is still remaining. So I will write here 10 को हम 1 से divide करने वाले हैं. 10 zeros are 0 and the remainder we are getting is 1. It means again I have to write the statement something like this. 1 raised to power 3, correct? So every time, if you notice, I have to do this operation, right? 3 raised to power 3. How am I supposed to do that? Can I write something like this? Temp modulus 10, whatever remainder you are getting, divide it, raised to power 8, because we already have a function which is called as the power function. Two values we have to provide to that power function. Number one value is of course the remainder. So I am directly typing here temp mod 10 rather than taking the remainder value. You can also take it there. And the second value is the count, that is temp modulus 10. For the first time it will be of course 3. So 3 comma 3, because the count key value is what? 3. So 3 raised to power 3, it will give us something value, and that value will be equal to 27, right? So initially sum key value will be 27 over here, correct? Now for the second iteration, again temp modulus 10. What is the value of temp over here? It will be 1, right? So 1, the remainder which we will get is 5, and I will write it down here 5 comma 3. 5 raised to power 3 is what? 125. We have to add this sum key value to this new sum key value, right? So we can write it for the generalized way something like this, right? So always save the value of the previous sum key value to the new sum key value. So now sum key value will be what? 27 plus 125. So what is the value of 125 plus 27? I think it is 152, right? Now in the next iteration as well, because we have remainder 1, so 1 and comma 3, right? And that will be equal to 1 again. What is the previous sum key value? So the previous sum key value is 152 and the new sum key value is 1, and the sum key value will become what? 153. Now I will just compare it with n. So n key value is 153 and sum key value is 153, and they are equal, leading up to the concept that yes, this is an Armstrong number. Hope you guys have got the logic of this program. Let us now move on to the coding section. So here I will be firstly taking a number, right? So I will be taking a number is equal to 153 for now, okay? I will be taking another variable temp, and I will be storing this value of num into the temp value. As we have discussed, I will be taking a count key value is equal to 0. So firstly, what are we supposed to do? We are supposed to iterate it so that we can find out the number of digits. So we will write down, while temp key value is greater than 0, because we have already discussed the logic, I will try to find out temp divided by 10, right? And I will increase the counter over here as we have discussed. After that, because the temp key value will get to 0, so I will again initialize the value of temp with the num key value. I am taking a variable sum which is equal to 0, then forward, while I will write it down, temp is again greater than 0. What we are going to do, we have to perform that sum wala operation. So sum will be equal to sum plus math dot power function I am going to use. So we have to write it down, temp modulus 10, or you can also write it for the remainder, and I will be writing here the value of count, right? And it will ask me to cast it to int, and I will be casting it to the integer value. So you can also do that, right? So temp key value is again I have to give it at the new digit by dividing it, right? Done over here also. So now I will be comparing it. If sum is equal to what? If sum is equal to num, it means this is an Armstrong number, right? Else not an Armstrong number. Hope you guys have got the concept. Let me just show you. We will be taking another number as well, say 154. So 154 का अगर हम देखेंगे 1 raised to power 3, 5 raised to power 3 and 4 raised to power 3. Let me just calculate it right now. Okay, 1 raised to power 3 is 1 plus 5 raised to power is 125 plus 4 raised to power 3. 4 raised to power 3 will be, I think, 64, right? So 64 plus 125, 64 plus 125 plus 1, I think it is 254, right? Which is of course not equal to 154, therefore it is not an Armstrong number. So guys, you can also find out the Armstrong number using this whole logic. Hope you guys have understood the concept wholly. Thank you very much.